guys ready?
Yes, ma'am.
Okay. Good morning, class.
Good morning, students.
Today we're going to understand that I can differentiate between weathering, erosion, and deposition and determine how they are related. So have you ever wondered how rocks get cracks?
Yeah.
How creek beds become looking like this?
Yeah.
How canyons are formed? How beach shorelines? Look at this. How did that happen? What about trees growing in rocks? Or sand dunes? How did they get there? Does anybody know? Well, today I have good news. That's what we're going to learn about. Okay? So, fill your rocks that are on your tray. I have a big rock. Have you ever wondered how a big rock with sharp edges like this got to be like the smooth rock that you have on your desk? How did it get that way? I don't know. Do you think that somebody goes around and puts sandpaper on the rocks and does it by hand?
No.
No? Okay. Well, today we're going to learn 3 terms that are going to give us the answers to how those things happen. We're going to learn weathering, erosion, and deposition. So once again, take your rock, squeeze it. Does anything happen when you squeeze it?
No, it just stays in its regular form.
Well, which of these terms do you think is the factor that causes things on the Earth's surface to change?
Erosion.
Erosion? Well, actually it's weathering. Weathering is a slow, destructive process in which rocks and other materials on the Earth's surface are broken down and changed over time. So weathering breaks things down, okay? And it can be chemical or mechanical. So the first one we're going to talk about is chemical. So I have a piece of chalk that's unweathered. You guys know what chalk looks like? It's smooth and it's round.
Yeah.
Real smooth edges.
Yeah.
But if I take vinegar, which has acid, which sometimes we can have acid rain. There's sometimes things in the air that get blown around and land on things. Let's see what happens when acid comes in contact with my chalk.
It's like dissolving. It's getting wet.
Look at it. I know for you guys in the back it might be a little hard to see, but there's bubbles beginning to form. So as class goes on, we're going to watch this and we'll come back and see what happened, okay? Because then I'm going to take another one and I'm going to pour water over it.
I love water.
And we'll see what happens with our water. So we'll cover that one with water. We're going to let these sit and we'll come back to them. Don't let me forget, okay?
You won't. I'll get remember.
So we have unweathered, one with acid for chemical weathering that we're going to watch. And then we just have regular water, okay? So not only can weathering be chemical, so if rocks come in contact with acid, like if something comes in over it in a creek, we pollute the earth, right? So therefore our pollution can cause acid in our creeks and our rivers. So it can cause chemical weathering. Fungi. So if you look at this rock here, you'll notice that there are some black specks, kind of green. So it was obviously, I got this rock from outside in my yard, so there was a fungus growing on it. So therefore, it starts to break it down and puts these pits inside. All right, the next type of weathering is mechanical. What do you think mechanical weathering is? Any ideas?
A building weather?
Chastity?
Breaking of rocks and.
So we know weathering is breaking them down, right? Chemicals can break them down, but we're talking about mechanical. What do you think the word mechanical could mean?
It breaks down by itself.
So mechanical is the process of some type of force, okay? Some kind of force has done it. So I've taken chalk, once again, and you're gonna practice this here in just a minute. And it's just regular chalk. This is unweathered from mechanical. But I took it home last night and I put it in a jar. And I put some salt in there to mimic like a rock being tossed around in a river and hitting other things. And look what happened. What did it do? It began to break down, right? Because look at my pieces.
They're all.
They're small. They have holes in them.
They're like that rock.
They're like that rock. Because the continuous forces of something hitting these pieces of chalk with my shaking caused it to become mechanically weathered. Even turned it green. You can tell it broke down because it turned my salt green.
Yeah.
Okay? So now what you're going to do is you have a sugar cube on your desk. And the first thing I want you to do is take this sheet that I've already placed on your desk, and it's about mechanical weathering, and we're going to make some observations. So take your pencil, and in this first box, I want you to draw what the sugar cube looks like right now. Look very closely at it. Pay attention to the edges. And draw exactly what that sugar cube looks like in your paper. On your paper. I'll give you just a minute to do that. Once you gotten your sugar cube drawn on your paper, what it looks like before we're going to mechanically mechanically weather it. You're going to take your marker after you draw it, and I want you to color one side of your sugar cube. No, on the sugar cube itself.
Oh.
Color one side of your sugar cube with your marker.
It's kind of hard because it's all sugary.
Yep, just color one side of it.
The whole side.
Yep, the whole side of the cube, just like this. And then you're going to take your little cup here, and you're going to put your sugar cube in there. It doesn't matter which way that colored side is, and you're going to put your lid on it. Raise your hand with your sugar cube and your thing with your lid when you're done, so I can make sure everybody's done. Got it, Jacob? All right. Put your lid on there tight. Everybody make sure it's snapped. All right, and now what we're going to do is we're going to shake them. Shake them hard. Okay, you can stop. So we're gonna let this sit just a few minutes, and we're gonna come back after we've talked about some more weathering, and we're gonna make some more observations about our sugar cube on our sheet, okay? So place it to the side. So that is another representation of like a rock being going through a running creek with water, being tossed around, okay? So do you think running water, like in creeks and streams and rivers, are the only type of mechanical weathering?
No.
What else do you think outside in our environment can cause mechanical weathering?
Rain.
Rain,
Earthquakes.
earthquakes, that goes pretty deep,
They're like the plates scratching on each other.
okay? So those are things within the Earth's surface and the structure of the Earth, okay? Think about other things. What happens when you go outside? What do you feel sometimes when you go outside?
Wind.
Wind. So we're going to demonstrate wind. So you each have a piece, wind weathering, you each have a piece of sandpaper. You're going to put your finger against the smooth side, okay? And you're going to take your rough rock, your gray rock, because you have a smooth rock there, and you're just going to rub on your rock. This is like wind, because is the wind clean? Do sometimes you feel things beating on your face when you're in the wind? Because it's picking up small things and floating them through the air. So find you an edge or a side and feel what it feels like, and then feel the difference after you've sanded on it for a minute. What did it do?
It got smooth.
It got starting to get smooth. Do you think this process of weathering happens overnight or within minutes? No, it takes what? Years. It takes time, right? Same thing with chemical weathering. It doesn't happen all the time. So over time, this is how your things that you see on the Earth's surface become weathered and change. Just like how a rock with sharp edges, unsmooth, over time can change to a smooth rock with rounded edges. It can even change colors because it can go through both kinds of weathering, chemical and mechanical. So it can change colors if certain chemicals get on there. All right, so we've talked about our first term, weathering. So weathering, look at me, weathering breaks down. So we're going to write that. Weathering breaks it. Yes. So weathering breaks it. Now we're going to talk about our next word, erosion. Because after it breaks, does it just stay there?
No.
No? If you want to move something from one place to another, how do you get something moved from one place to another?
I use my hands.
You use your hands and you do what? I pick it up and I move it. Well, somebody gonna go outside and pick up all the rocks and move them where they go?
No.
Well, how could they get there?
The water.
Water? What else might move them?
Wind.
Wind? What else?
Storms.
Storms? What?
Tornado. Floods.
Floods? So, water, running water, rainfall, wind, all of those things can cause things to, what's weathered that's broken, what causes erosion. So erosion is when what's been broken moves. Okay? So if it's been broken, it has to move through some way. Wind or water. Somebody could possibly pick it up. So erosion is going to move it. All right? Does that make sense?
Yep.
All right. So we're going to do a demonstration now. Let me get this table out of the way. I'm going to bring my big table over here. And we're going to put all of this together, and then we're going to learn what this term means, okay? All right, I'm sorry if you guys in the back can't see real well, but you'll be able to look at it, okay? So first I'm going to take, this is what I have made as a riverbank. It's dry right now. So I have a dry riverbank. There's no water running, but I can see that there is a basin here, right? So the first thing I'm going to do is I'm going to pour water into my river. Watch what happens as I pour it. What happens to the side? It begins to what? It begins to break down. And then what happened to my sand? What did it do? It moved it. So my water running through my river breaks down the edges, moves my sand and sediments, and then the last term that you see is deposition. So as I continue to pour water, what begins to happen? So it's moved. What does the sand begin to do at the bottom?
Change.
It stops, right? Does it go anywhere? No. So deposition is where it is deposited, where it stops. Okay? Just like if you guys put money in an account, it stops there, right? Until you move it somewhere else. So deposition is the stop portion of this. So we broke it, we moved it, now we have stopped it. So let's write stops it. All right. But like we said, is running water in creeks and rivers the only thing that can cause weathering, erosion, and deposition?
No.
What else might?
Rain.
Rain? Would you like to see?
I can't see very well because
What did it do? It moved it. First it, then it moved it. It stopped it. All right. What else might? Besides rainfall, running water, wind. Let's see how much hot air I have. You ready? Can you see it moving, you guys on the front? Macy just got some on her paper. So I moved it, right? I broke it, I moved it, and then where did it go? It stopped somewhere, right? It's kind of hard to blow. So, we know that running water, wind, and rainfall can cause weathering, erosion, and deposition, right? So, we're going to review, and I'm going to make you practice with me. So, weathering breaks it. Erosion moves it. And deposition stops it. All right, so stand up behind your chairs, and let's practice this one time, okay? Let's do it. Are you guys ready? So, weathering breaks it. Erosion moves it. Deposition stops it. All right, one more time. You ready?
Yep.
Weathering
Breaks it.
erosion
Moves it.
deposition.
Stops it.
All right, I'm going to say what it does, and you're going to say the word, okay? Breaks it.
Weathering.
All right. Moves it.
Erosion.
Stops it.
Deposition.
Very good. All right, so now we're going to finish up your sugar cube weathering experiment sheet, and then we're going to fill out a study guide so that you can study, and you will take an assessment on this on Monday. of next week, okay? So have a seat back in your chairs.